Greetings. I'd like to take an opportunity to go through area models using base 10 pieces, looking at 4th grade, 5th grade, and then moving into 6th grade, just so we can see how they've been progressing. So our first example is 574 times 8. We like to think of this as finding 574 groups of 8 or 8 groups of 578. So what I did with my base 10 pieces was I made 574 and I want 8 groups of that. So I want 8 groups of 574. So here are 8 groups of them. I see then when I count them all together that I have 40 hundreds, 56 tens, and 32 ones. Well, we're going to end up having to regroup. So I'm going to start with my ones and regroup my ones because I can make some tens or some longs out of my ones. So I'm going to change my ones to 3 tens and 2 ones left over. That then gives me 59 tens. But I know that I can regroup some tens into some flats, so some tens into some hundreds. So I know that there are 5 hundreds then and 9 tens left over, giving me a total then of 45 flats or 45 hundreds. Again, I can regroup them into thousands. These would look like a cube, as we know. So this would give me 4 thousands and 5 hundreds left over. So I can read this then as 4,592. We could also use a more condensed version since this is kind of long, and using the base 10 pieces, there's lots of them. So notice along the top I wrote 574 in its expanded form, so 500 plus 70 plus 4. And on the left I have 8. So I can take each box times its area, hence the area model. So 8 times 500 is 4,000. 8 times 70 is 560, and 8 times 4 is 32. So when I add them all together, I also get 4,592. It's a little more condensed version as students are seeing how they're building and complexing together. Let's try 42 times 73. So we want to find 42 groups of 73 or vice versa, 73 groups of 42. So I'm going to do a different approach. It's still an array model here. Notice along the left-hand side, I've got 10, 20, 30, 42. And along the top, I have 10, 20, 30, 40, 50, 60, 73. And notice that they're not lined up perfectly here. But what I want to do is fill in the rest of this area into a rectangle so that we can use an area model or an array model. So notice that I would need a flat to fill this area here all the way across. And to fill in these individual unit areas, I would need a long or a 10 rod. And then I continue until we're full. Notice then that these crosshairs represent 42 times 73. So then the area we can count what created our rectangle. So I see that there are 2,800 in my flats here. In my rods down below here, so this little area, I have 140. I have 120 in this area. And in my final area, the little units, I end up with 6. Adding them all together, 2,800 plus 120 plus 140 plus 6 gives me 3,066. So if I also want to use this using the box kind of method, the area model that we used in the previous example, I would have written in expanded form 40 times 2, or 40 plus 2 for 42, and 70 plus 3, writing in its expanded form. So notice this time, instead of on the left having 42, I have on the left 73, and on the top I have 42. To show you that it doesn't matter in which way we do this, we're still going to end up with the same result. So 70 times 40 is 2,800. Notice we did get that area here. 70 times 2 gave me 140. We got that area down below. 3 times 120, or 3 times 40 gives me 120, this area here. And 3 times 2 gives me 6. Again, if I were to add them all together, I would still get 3,066. So a little more condensed version. 23 times 630, so we want to find 23 groups of 630 or 630 groups of 23. Again, I'm going to use the area model here just to expand our notation a little bit here. So along the top, I've got 600 plus 30 plus 0 written in expanded form, and 20 plus 3 to represent 23 in expanded form. So 20 times 600 is 12,000. 20 times 30 is 600 and 0, so 20 times 0. 3 times 600 is 1,800. 3 times 30 is 90, and 3 times 0 is 0. Adding them all together, we see we end up with 14,490. So then let's compare that to the model of our standard notation. So I want to take 630 times 23. So I know that 3 times 0 is 0. 3 times 3 is 9, and 3 times 6 is 18. We put a space or a 0. Some of you might put a 0, but we just put a placeholder since we're shifting. We're actually taking 20 times all of these, which is where that placeholder comes in. So 2 times 0 is 0, 3 times 2 is 6, and 6 times 2 is 12. Adding them all together, we get 14,490. So we can see that those pieces are built. So notice if I were to add these across here, 12,000 plus 600 plus 0 would give me 12,600, and 1,800 plus 90 would give me 1,890. So they're all interconnected. It's just a matter of ways that students can see them and build them together. In 4th grade, we're only being introduced to decimals. But once we are, we can see the connection between using the same types of modeling in the 5th grade. So let's say I want to take 4/10 times 2. So once we're in the 5th grade, we're actually using decimals, not just introducing them. We want to find 2 groups of 4/10. So let's say the rod is our whole. That would mean that 4 units would give us 4/10, and I want 2 copies of that. So there's 1 copy and 2 copies. So then all together, I see that we have 8/10. Similarly, let's say I use the flat as my whole. That would mean that 4 rods would be 4/10, and if I want 2 copies, we would also receive 8/10. So you have to be specific on what you want your whole to be. Let's say I want 5/10 times 3/10. So here is our whole, the flat. I'm going to take and shade 5/10 of them, so half of them, one way, and I'm going to shade 3/10 going the other way. Notice that there is a location in which they overlap. I count that overlapping location, and I see that there are 1,500ths. So 5/10 times 3/10 is 1,500ths. Let's try 4/10 times 62/100ths. Let's estimate first. Let's take 4/10 times 5/10. Using the model from the previous example, we would see that we would end up with 20 hundredths. So our answer should be about 20 hundredths. So let's use the same model that we used using the area model earlier. I want to take 4 times 60 plus 2. So notice I'm just dropping the decimal, ignoring it completely. But I'm still writing them in expanded form. So 62/100ths is the same as 60 plus 2, just ignoring the decimal. And 4/10 is the same as just 4. So when I multiply 4 times 60, we get 240, and 4 times 2 is 8. Adding them together, I get 248. But our estimation said 20 hundredths. Therefore, we need to move my decimal to be 0.248,000. So 248 thousandths. using our estimation to help us determine where the placement of our decimal should be. Using the standard algorithm, we will multiply 4/10 times 62/100. So 4 times 2 gives me 8. 2 times 0 is 0. So we need a placeholder. 6 times 4 is 24. And notice we end up with 8 and 240, noticing that the 0 here would be a part of our placeholder. When I add them together, we get 248. Using the standard algorithm, we count the decimals 1, 2, 3 to give us 248 thousandths. Let's try 1 7/10 times 12 hundredths. Let's estimate first. I'm going to estimate this to be 2 times a fourth. And a fourth, 2 times 1/4 is half. So our answer should be about half or so. Again, I'm just ignoring my decimal places. I'm thinking this is almost quote unquote 17 times 12, which would be 10 plus 7 and 10 plus 2. Again, order doesn't matter. I could have 10 plus 7 down below or 10 plus 2 up above. So 10 times 10 is 100. 10 times 7 is 70. 2 times 10 is 20, and 2 times 7 is 14. Adding them all together, we end up with 204. Well, our estimate says it should be about half, so our decimal should give us 204 thousandths, so our decimal should go before the 2. Using the standard algorithm, 7 times 2 is 14. Carrying the 1, we'd have 7 times 1, which is 7, plus 1, which is 8. We need a placeholder. 1 times 2 is 2, 1 times 1 is 1. Adding them together, we get 204. Adding our decimals, 1, 2, 3, moves to 0.24. Let's do a couple divisions. I have 72 hundredths divided by 8 hundredths. We're asking how many 8 hundredths are in 72 hundredths. So how many 8 hundredths can go into 72 hundredths? I'm going to start off by using my flat, my base 10 flat, so I know that there are 100 in here. I shaded 72 of them to represent 72 hundredths. And I'm going to partition them off by grouping them into 8 hundredths. So here's 1. There's 2 of them. I'm going to keep going until I cover them all. And I see that there are 9 groups of 8 hundredths that make up 72 hundredths. Let's take 9 and 2/10 divided by 4. We're asking how many groups of 4 can we make from 9 and 2/10. So I'm going to start off with 9 and 2/10. So therefore my flats each represent a whole. So I have 9 wholes and then 2/10 more. And I'm going to put them into 4 groups. So I can take these 4 here and put them and give them each into a group. But I have 4 more, so I can split these apart and then each group gets another flat. But I don't have enough flats to evenly distribute into each group. So I'm going to turn these flats into 10, 11, 12 longs. And I'm going to distribute my 12 longs into 4 groups so that each group gets 3 longs. Therefore, each group has 2 whole units and 3/10.